Let us solve one more example on mesh analysis. The statement of this example is, by mesh analysis, find the current through 2 ohm resistor in the circuit given below. So this is the circuit given and we have to find out current through 2 ohm resistor by applying mesh analysis. Let us redraw the circuit and we will assign different nodes and mesh currents. Let us mark the nodes A, B, C, D, E, F, and let us mark the loop currents I1 and I2. I have assumed the direction of both currents to be clockwise. Now there exists a current source in the circuit, that is 6 ampere. So while writing down equation of loop A, B, E, D, A, we have to consider this current source. If there exists a current source in any mesh of the circuit, then Kirchhoff's voltage law cannot be applied to such mesh, as voltage drop across this current source is unknown. Also, the mesh A, B, E, D, A is having current source 6 ampere. This indicates total current flowing through this mesh will be 6 ampere. Hence, the current source is expressed in terms of mesh current, that is, current source of 6 ampere in the direction of mesh current I1. So, we can write down the equation as, for loop I1 is equal to 6, that is, the whole current through A, B, E, D, A is nothing but 6 ampere, which is I1 as per our assumed value. Now apply KVL to remaining mesh B, C, F, E, B. Now moving from B to C, we have a 5 ohm resistor. Hence the voltage drop across 5 ohm resistor reduced due to I2 will have negative sign, because the loop direction is B to C and current direction is also B to C. So the value of this voltage drop will be minus 5I2. Then from C to F we have a source, voltage source. Moving from C to F, the first terminal appears to be positive and second terminal appears to be negative. So there is a drop in voltage, or we are moving from positive potential to negative potential. Hence, as per sign convention, this 10 volt will be indicated in equation as minus 10 volt. F to E, there is nothing connected. E to B, there is a resistance 2 ohm. Now again this 2 ohm resistor is common to both nodes. F to E, no element is connected. E to B, there is a resistance of 2 ohm value, which is common to both mesh I1 and I2. Hence current flowing through 2 ohm will be resultant of I1 and I2. Now we are in loop 2 or mesh 2. So mesh 2 current will be assumed to be higher than mesh 1 current. Hence voltage drop across 2 ohm resistor will be considered as minus 2 I2 minus I1. I2 minus I1 is the difference between two currents, assuming I2 to be higher than I1. Negative sign indicates we are moving from E to B in the loop. Loop direction is E to B and my current direction is also E to B. Hence both directions are same. So as per sign convention, voltage drop will be considered as minus or negative. Now we got values of all element voltage drops. So we can write down the equation of loop as, for loop or mesh B, C, F, E, A. Equation will be, first element is minus 5I2, second element is minus 10 volt and third element is minus 2 I2 minus I1 is equal to 0. So addition of EMF sources and voltage drops is equal to 0. Simplifying equation, we'll get plus 2I1 minus 7I2 is equal to 10. Equation number 2. Now solving equation number 1 and 2, we get I2 is equal to 0.2857 ampere. So we have value of I1, we have value of I2. Now current through 2 ohm resistor is resultant of two currents because 2 ohm is common to mesh 1 and mesh 2. Now if you look the values of I1 and I2, I1 appears to be greater than I2. Hence, current through 2 ohm resistor is given by I1 minus I2, that is 6 minus 0.2857, that is equal to 5.71 ampere, and the direction of current is downward. So resultant current will be flowing. So this is direction of actual current in 2 ohm resistor with the value 5.271 ampere. This is answer of our question. Thank you for watching this video.